Hi everybody, welcome to my session. My name is Dan. I hope you're really enjoying Build Stuff. Today I'm going to talk about how we measure and improve performance for 100 million websites hosted on the Wix platform. Where's my clicker? Here we go. So I'm going to talk about the methods that we use, the techniques to measure performance from the endpoint primarily, so you could say it from the end user perspective. And then I'm going to talk about some of the lessons that we've learned as results of these measurements and hopefully give you tools and tips that you can apply in your own websites and web apps, even if you're not yet as big as Wix. So a few words about myself. As I said, my name is Dan. I've been with Wix for slightly over 2 years. My role at Wix is that of a performance specialist, which means that on a good day, I get to come home and tell my wife that today I made 100 million websites load and execute faster, which is actually a significant proportion of the web, relatively speaking, of course, which doesn't really impress her that much because she's not really into tech. A few words about Wix itself. So I've already mentioned we've got 100 million websites. You might have noticed that on the slide talking about this talk, it said 90 million. That's because we're growing very quickly. So it used to be 90 million, now it's 100 million. We've got 1.5 million different domains hosted by Wix. Another interesting number is 50 million page views per day. 2 billion HTTP requests. And a lot of those, by the way, have to do with monitoring. 80% year-over-year growth in traffic. We are really growing very, very quickly. We have a change pushed out to production in this system approximately every 7 minutes. That's the rate of change in our systems. And we're running on 3 different data centers plus 2 clouds, both Amazon and Google. Oh, and by the way, if you're really good, we're also hiring. Okay then, so let's talk about how we actually measure performance given all these numbers. So the obvious tools for measuring performance if you're building web applications is any development environment that's integrated into the browser of your choice. Personally, I really love the Chrome DevTools. Everything else kind of feels weird and different and with stuff in the wrong place. And Chrome DevTools, for example, have this great 2 tabs for measuring performance, the network tab and the timeline tab. So you can use those. And by the way, in case you don't know, you can actually save the results of this tab and then have it sent over. So if you've got somebody on a support session with a customer who's complaining about performance, you can have her create, open this, create the network view and then save it and then send it over to you and you can check it out this way. So if you're looking to improve performance in your web application or website, the Chrome DevTools or whatever DevTools you like, that's probably the first place to go. The problem with that, though, is that you're measuring performance on your device. Now, Chrome DevTools, for example, have the ability to throttle network and currently even CPU, but it's still not quite the same thing as actually measuring out in the field. You can go a step further by using a tool such as webpagetest.org, which lets you run these types of performance tests from various locations in the world, various browsers, various simulated devices, and so forth. And this way you can get a much better understanding of how your website is performing, not just from your location, but from anywhere in the world. And in addition, you can even automate this, so you can prepare your own set of virtual machines to run tests from various locations in the world, and you can get notifications and warnings if you see that your performance is, let's say, degrading beyond a certain point. So it's really, if you've got an automated process for deployment, you can include this as part of your automation. But even though this allows you to run your tests from various locations, at the end of the day, you're still working in a simulated environment. This is not really what your users are necessarily experiencing. So to take a step to take it a step further, you need to go beyond just using tools like that. And for that, I have two words: keep it real. And by that, I mean use data from production. Gather actual data from what your users are experiencing, because that's the best data that there is. So let's look at some of the data that we're collecting at Wix. And there's nothing magical about it. Everything that I'm showing you that we're collecting is stuff that you can collect as well, and I'll be talking about how you can do that. So for example, do you measure the DNS time for your web services or web applications or websites? Because these days, a site can incorporate data coming down from multiple domains. So the DNS lookup time can become significant. So we do. We actually measure DNS time. And what you're seeing here is the median DNS time from all over the world for people visiting Wix sites. So the values on the left are in milliseconds. So we're seeing approximately 150, more or less, in that particular time frame. Another interesting one is the response time. That's the time that it takes from the request being sent out from the browser when the user clicks a link or chooses it from the bookmarks, whatever, and until the first byte is received from the HTML reply over HTTP. And here you've got two lines. The blue line is the current response time, and the yellow line is the one from the same time range a week before. So we can also compare and see if we're improving or degrading and what's going on. We also measure the performance of the web application in terms of it's these days when you get back the HTML response, that's just the beginning of the story. Because really, in a lot of websites today, when you incorporate frameworks such as Angular or React, a lot of the rendering goes on the client side. So it's not just enough to measure those aspects of the network. So here we're looking at the performance of a web application, in this case the viewer web application, which is our web applications which render the sites that users built with Wix. And we're looking at it not just from the perspective of when it started and when it finished. We've divided it up into various stages, and we're measuring the time of each and every stage. And so in this example, the baseline, the 0 point, is when that HTML was received. The red line is when our Bootstrap finished loading and executing. And then you've got the light blue line, which is when the JavaScript file libraries that we're using, React and our own libraries in this case, have been fully downloaded and initiated. And finally, the dark blue line at the top is when the site is fully rendered. You know, it's an interesting discussion what we mean by fully, but for the sake of this discussion, let's hold off on that. So what's the advantage of seeing all these lines is that it allows us to understand where our applications is spending the majority of the time. And we can see where it's worthwhile to concentrate our efforts. For example, we can see that approximately 50% of the time, if not more, is just waiting for the JavaScript libraries to download and be initialized. So obviously that's a place that's worthwhile investing effort in. It also shows us the impact of various changes we made in the system. I've mentioned before, a change every 7 minutes. So it's very easy to slowly start degrading without even noticing. And being able to view this information in such detail is very important if you want to prevent degradation. Here's another thing that we measure. This has to do with the time to first byte for media files that we download. We actually look, images, videos, whatnot. We actually measure the amount of time it takes from when the request was issued by our client and until we got the first byte of the response. Modern browsers let you do that, and I'll talk about this in a bit. So the line at the top is the median value, and the line on the bottom is 95%. So you see that for lucky people, they get the media, the time to first byte is under 200 something milliseconds, whereas for the poor people with really slow internet connections, they have to wait as long as 2 seconds for the byte just to start arriving. Here's another interesting one. That's kilobytes per second. That's actually compared, looking at, we know the size of the resources. And in our case, it's a bit more complex. But if you're building a website, you should generally know the size of your resources. And then you can look at the total amount of time it took to download them. And from that, you can measure kilobytes per second. So that's what we're seeing here. Again, the median value and the 95 percentile. Any questions so far? Okay, going on. This actually made the news. You remember a few weeks ago when there was this big DDoS attack on the DINE, I think it's called, DNS Provider, basically shut down half the internet. Twitter didn't work, other services as well. We were impacted as well because we were using that DNS. And so our servers remained up, but people who were doing, trying to navigate to Wix sites were impacted because the DNS took either a really long time or just failed completely. So if you remember that DNS lookup time graph, this is what it looks like when the DNS is under a DDoS attack. And these are the reports from sites that from sessions that actually managed to load. So you can see the obvious spike. And we saw the attack in our graphs literally within the minute of when it started. And we got alerts from our system with under 10 minutes. And the first support calls started arriving approximately 15, 20 minutes afterwards. So this type of monitoring also gives you significant heads up when you're trying to understand the quality of your service and whether it's up or not and what's going on. So far, we've looked at systems and graphs that we've basically implemented on top of our product. That means they didn't really impact the developers themselves. I might go to a developer and tell them, look, the change that you've made really made everything slower, but the developers themselves were not directly involved in the performance measurements. The performance measurements were built in from the outside, from the top. But if we really want to be able to measure specific processes within the web applications, we need to go a step beyond that. We need to level up, as it were. And in order to do that, what we've done is we provided the developers with a performance API that they can use from within the application. So if they want to make a change, for example, they can see the impact of the change they're making, whether it improves performance or degrades performance. So how does this API look like? It's actually a fairly simple API. As I said, we measure applicative operations, including asynchronous operations. So a developer can, in fact, start a measurement, perform, let's say, an AJAX request, get the reply, process the reply, update the display, and measure that entire thing as a single logical unit, if that's what she needs. So the simple API basically looks like this. You have a start method that you can call, giving it a unique name, identifier name, and then you have a finish call where you specify the matching name which ends that specific measurement. And there's an additional optional report argument which I'll talk about in a second. So that's all that's needed. Now this is in fact implemented on top of a W3C standard API that's currently implemented by the majority of browsers, which is the Performance Mark API and Performance Measure API. I don't know if you're familiar with these APIs. They're standard. They're implemented in Chrome, Firefox, latest versions of Safari, and so forth. And they were created specifically to enable developers to measure operations. Now, why did we wrap them? We wrapped them for several reasons. First of all, to make them somewhat easier to use. Also, to make it so that if they don't exist, the application doesn't fail. So the wrapper is smart enough to check whether or not they exist, and if they don't exist, either provide a shim or just do nothing. So the developer can use our API and just leave it in the code, and they don't have to worry. And in fact, these APIs do exist in our production code. one really cool thing about these W3C APIs is that, well, you can access the values that you gathered using them from the dev console. But in the case of the Chrome DevTools, for example, you can actually see the results graphically, visually, integrated into the timeline view in the Chrome DevTools. I will show you that in a second. And another thing is, going back to that report argument, the optional report argument, if the developer specifies a truthy value there, that measurement is actually reported back to our backend, which lets the developer gather information from production. So you saw the information that we gathered, generic information that we were gathering from production. This lets you gather specific applicative information from production about, you know, various aspects of the behavior of the application. So how does it look like in Chrome DevTools? This is it. If you've had a chance to use a later version of the Chrome DevTools, in the Chrome timeline, if you've used the mark and measure APIs, or in our case, the wrappers, you will get the user timings. I apologize that it's so small, but they are actually color-coded, and you can't really see it, unfortunately, but the strings inside there are actually the names that the user put in the API. So this way, the developer can quickly find in the DevTools the section that he's marked, just look at what the JavaScript was doing during that time, looking what's going on in terms of the network, even seeing screenshots of how the screen evolves. And as you can see, you can have multiple ones overlapping, and then they're just lines one below the other. So you can see several processes in tandem. This is how it looks gathered from production into our system. In this case, we're actually using a third-party product that we have a license for called New Relic. New Relic is a product that you can use for gathering performance information and whatnot about web applications. In this case, we're actually using one of their products called New Relic Insights, which provides you with APIs to send information from web applications using JavaScript back into their servers. And up there we have a query written in their NRQL language, and we just gave the developers several queries that they can use, and this one just shows you again the median 90% and 95% of a particular logical operation within the application. So this way, if a developer says, I think I can take a certain piece of code and make it faster, you can tell them, prove it. First do it on your computer, see how that works out, and then we can open it to, we have a whole mechanism for doing experiments, so we can open it to certain subset of our sessions, subset of our users, and compare that and have, graph of where the previous code existed and the current code exists, and we can see if it in fact improved or maybe degraded, maybe didn't make any difference. We can also filter by geo, by browser type, by device type, and so forth, so it's really powerful. So let's talk about the system that gathers all this information. First, though, there's this big question whenever you build this type of systems of build versus buy, because both options exist. We Wix, we in fact do both. So we already saw New Relic. It's an actual standalone solution that we're also using. It has some good parts. It has some not so good parts. Overall, we like it. We would like it to be better. It's not cheap, but it's fairly powerful. There's also another solution, a third-party solution that we're using called Anodot, which we use to graph and also identify anomalies and generate alerts for those. That one doesn't actually do its own collection of data. Instead, we need to integrate it into our solution and push data into it. Why are we using both build and buy? In our case, because we can afford it, and we like having the redundancy and validation, because if there's a problem with our system, then we can compare it to New Relic and vice versa. The other thing we found is that unfortunately no third-party solution that we looked at provided all the features and functionality that we wanted to have in our solution. For example, a lot of third-party solutions still look at at the performance of web applications in the context of standard events like onload or onDocument-ready, these types of events are effectively meaningless for modern single-page applications and just didn't do anything for us. So if you remember that graph with the stages that I showed before, those were all events that we created ourselves rather than relying on the generic events provided by third-party applications. So if you look at a third-party application, you need to verify that you're not just getting the onload. You want to be able to push your own custom events into the system and see them in there. And if they can't do that, well, then it's, from my perspective, it's worthless. Also, another thing you need to remember about third-party solutions is that they can be expensive, and often they charge you based on the amount of data that you're collecting. They can, in fact, be so expensive that it might be cheaper to build your own system and have a person, hire a person to take care of it instead of paying the amount of money that you would need to pay for them hosting your data. Another interesting thing is, we live in the age of open source. That's been talked about in this conference several times, and open source tools make it easier to build your own solution. So here's what our solution looks like. I've already mentioned New Relic, and the other thing is we gathered information from the browser into our own Nginx servers by performing an HTTP GET request, a single pixel request. It's a dummy request. We're asking for an image, and we get back a single pixel image that we don't really care about and aren't waiting for. We're just using it as a means to send information to that server. That server then writes this information into a log, and that log is read by an open source tool called Apache Flume, which basically is a tool for reading logs, parsing them, validating their values, and so forth. We have our own solution called the tool, let's call it, called the Wix BI catalog, which users use or developers use to define custom events, including parameters, and then Flume reads the information from there, it's essentially a simple database, and uses it to validate or parse and validate the information that it reads from the log. That information then gets pushed into two targets. One is effectively an Hadoop database that we use for persistent storage. So if we want to make complicated queries or long-term queries, essentially anything going in there stays there forever. So that just grows and grows and grows, and we can do all sorts of queries and whatever our business analysts can think that it's worthwhile querying, they can do that on top of the Hadoop. And we have real-time monitoring where we push it into Apache Spark and do much simpler parsing, but that gives us very detailed, just-in-time graphs. The graphs that you were seeing before about the DNS and lookup and whatnot, those are coming through that. From Spark, it gets fed into Grafana and into Anodot. So those are the systems that we use to do the real-time viewing. And Anodot also gives us the alerts. Unfortunately, you probably can't see this very well in the back. This is the interface for our BI catalog application. Basically, it lets the developers define custom events, making sure that event IDs are unique, and specify the fields for events. The fields can be strings, they can be numbers, they can be Boolean values, and you can actually, if you want something more complex, you can just take some JSON and stick it into a string field. It makes it more difficult to parse, but still workable. I mentioned that we send this information using a single pixel HTTP GET request. So why do we do it that way? Because when you're asking for images, there are no CORS issues. We don't care about the image sent. We don't try to look inside of it. And we don't wait for the response, and we obviously use a cache buster. And another obvious thing is that you need to be careful about not sending confidential user data when you're doing BI just for monitoring purposes, because users really don't like that. One thing, though, is that the way that we're doing it, we're in the amount of data that we're sending on a single request, we're limited by the URL length, and this is essentially how it looks like. A lot of fields in there. forget about them. The three interesting ones are the SRC is basically the category of the event. The EVID is a specific ID of the event within that category. And for every event that we send, we also send a TS value, which is the amount of milliseconds that have passed since the 0 point for the page. That's when the navigation event occurred. We built all this thing above the Web Performance API that's standard part of HTML5. So that means that you can do this as well if you want to build your own solution. There's performance timing, which gives you timing information for the page. You can use it to look at, the DNS time, the SSL handshake, the time to establish a TCP connection, all the interesting values about timings for the page itself. There's get entries, which you can use to obtain similar information about every other resource that you download. So if you have a large JavaScript file and you want to know how long that takes to download, you can use that. There's also navigation type, which is important because it tells you how the page was navigated to, whether it's just a regular navigation or whether it's a page reload. For example, you might see that if your page is slow to load, a user might be clicking F5 in the middle because he hopes that maybe that will cause it to load faster. And in fact, the funny thing is that in a sense it does, because when you reload, hopefully some of the information is already in the cache, and then it loads faster. So at least, the total time hasn't shrunk, but the user feels that he's doing something. So with navigation type, you can see that this is happening, and be aware that the time you might want to distinguish in your measurements between sessions that just load when the user clicked on a link versus sessions that occurred because the users get fed up and do an F5. As I said, it's applied with all modern browsers. Okay, so we talked all this time about how we measure performance. Let's now talk about how we improve performance. By the way, how am I doing for time? I have no idea what time it is. I've got 20 minutes left? Oh, okay, it's 3:20. I have no idea what that means.
You have 20 minutes.
Oh, I have 20 minutes. Okay. So let's talk about improving performance, because we all like to improve our performance when it counts. Okay, so I'm really in favor of the Rail model, which is a model that Google is pushing or promoting for measuring and improving performance. Rail basically stands for response, which is how quickly the web app responds to some user interaction. User clicks a button, drags, hovers, whatever. You want that to be in under 100 milliseconds. That's what those numbers are, the numbers that Google is pushing for. It doesn't mean that we are or you are there yet. That's what they're pushing the web to achieve. There's the animation time, where you want to hit 60 FPS if you're lucky, which gives you under 16 milliseconds to do whatever you want to do. In fact, you have less because the browser also has to do some stuff itself. Idle basically means that whenever you need to do something complex, you want to do it in a time where the browser is idle. So you want to, let's say, not do a lot of things during the load up phase when the user is waiting to see something. You might wait until after something is shown to the user. So the whole concept of above the fold content and below the fold content has to do with that. And another one, the final one, is the load time, which is simply the time it takes for the page to load. And Google wants that to be under 1 second, which is easier said than done, especially on mobile devices. So in this session, I'll concentrate on the load one, because the load is the easiest to measure in production. And in this talk, I'm talking about applying information gathered from production. We try to measure the other ones as well, but realistically, measuring animation can be fairly difficult. How do you gather this information? How if animation starts out quick in the same session, then slows down, how do you report the different values? So load time is easy because usually a website loads once, in a session. So you're measuring that one thing, and it's usually long enough to measure, and so forth. So how do we measure? So looking at loading resources and how we can improve the time that it takes. So it was talked about in the keynote, and one of the keynotes on the first day. Use HTTP2. HTTP2 does multiplexing. It makes it makes loading resources faster in most cases, not all cases. You should measure to see whether it improves or not in your case. It might even degrade in certain scenarios. I will actually show you a graph of how HTTP2 impacts our own load time. Don't overbundle. You know, these days it's become very popular to bundle all the resources together. We have a Webpack, we use Webpack, or maybe you're still using Browserify, and you're packing all your resources, maybe even the CSS, and maybe even some images into this one big JavaScript bundle, then you push down the pipe. And I've seen sites use bundles that are in excess of 0.5 MB. And the problem with that is that you overbundle, you can't optionally download certain resources. If there's something that I only need once in a while, but if it's part of my bundle, it's there. I can't decide not to use it this time. Another problem is that I can't do, if all my resources are in the bundle, then I can't defer some of the things to a later time because it all is brought down up front. And obviously, as long as the bundle is downloading, nothing is happening. So if you're talking about 0.5 MB bundle, the user is just waiting around, waiting for this bundle to download and potentially not seeing anything on the website before that happens. And you know, on slower connections, on cellular phones, that can be a long time. And also, when you bundle everything, every change that you make changes the bundle, which means that every change that you make is effectively a cache buster. So all these are bad things that happen when you overbundle. On the other hand, there are some things to beware if you don't bundle. If you're not bundling, you need to be careful that you're not doing your downloads sequentially. That means if I need to get 2 resources and I say, okay, I won't bundle, I'll separate them, but then I download the first one and only when it's done I download the second one, I've only made everything worse. So I want to download them in parallel. Another thing to remember is that bigger files, especially text files, gzip better. So if you use a lot of very small files, you'll actually find that you're downloading more information, well, not more information, but more bytes. Same amount of information, but in more bytes. So I talked about the impact of HTTP2. We actually, for technical reasons, disabled HTTP2 for a while in some of our geos, and then we turned it back on again, and this is what happens. So as you can see, the graph fluctuates over time in any event, which can make it sometimes difficult to analyze what's going on. That's why you need to want to compare to what happened the day before or the week before. But you can definitely see that when HTTP2 was enabled, performance improved. It didn't improve like by, twice, but it did improve by approximately 20-something%, which is nice for the phase, specifically for the phase of downloading the JavaScript resources. So if you're thinking about the benefit of HTTP2, here it is in real life. Another thing that you want to do is you want to be smart about the way that you cache data. So first and foremost, it's expensive, but if you can afford it, do use a CDN, especially if you have customers in other countries from where your servers are at. Because the further away they are from your servers, the more they have to wait. And CDNs have this great thing that they're spread all over the world and they're caching everywhere. And it results in really good performance for users, let's say in Australia, wherever you happen to be serving users and you don't have servers. You should monitor the CDNs. Sometimes CDNs have bugs. You'd be surprised. We saw a scenario, I won't name the CDN, but we saw a scenario that the performance in Australia slowed down by a factor of 3. And when we told them about it, they fixed it. But, if we hadn't have told them, it might have stayed that way. Use proper cache settings in your HTTP header. Make sure that if it's a resource that doesn't change very often, you tell the browser to cache it. That way, It's cached. And again, it was mentioned in the first day talk, nothing beats the local cache. Service workers for commonly visited sites. If your users are coming to your sites a lot, then you should definitely use a service worker to cache information as much as possible. By the way, one thing that I found amusing, again, in that keynote was he said, you can't rely on HTTP cache because you can't cache everything. So we use a service worker and we use it to cache everything. So I don't know if you remember him saying that, but that's actually what he said. So yeah. And a very cheap technique that a lot of people are not familiar with for some reason is to use link prefetching. That means putting a link tag either in your head area, let's say, in your HTML page, or you can also put it in the HTTP response. And there are some interesting settings you can put there. There's the rel equals prefetch, which, as its name implies, basically says, I'm going to need that resources at some later stage in my session. Go ahead and prefetch it for me. So, you know, and then when it's actually needed, it's already in the local cache. Another one is pre-connect. Pre-connect says establish a connection. By the way, prefetch is supported more or less everywhere, as I recall. I need to check. It's actually in the notes in the slide. So if you look at the presentation afterwards, and of course you can check using can I use. But on the downside, if it doesn't do any good, it just doesn't do any harm. The browser just ignores it. So prefetch. Pre-connect is similar to prefetch, but it just does everything just to the point of before starting the fetch. So it means it does the DNS lookup, it does the SSL, the TCP connection, the SSL handshake, all this good stuff, and then it waits, keeping that connection open. So if you know that, for example, that you are going to be downloading something from that domain, you don't know what yet, you can use pre-connect so that when you do get to that point, things happen faster. And then there's the atom bomb, pre-render. Pre-render effectively takes that entire link and creates a virtual browser tab hidden from the user and basically just opens that site within that tab. And if the user then goes to that tab, then the browser just swaps that in and it's instantaneous. But obviously the downside is that if the user doesn't go there, well, you've just downloaded a whole site that the user doesn't care about. By the way, because it happens in its own separate tab/process, you won't even see those files being downloaded in the Chrome DevTools because they're not within that tab context. Prefetch you will actually see. By the way, pre-render can also be used as well, you know what, I don't have time for that. Grab me later for other tips about how to use pre-render for potentially optimizing your site. Avoid blocking. Don't block. Never ever block. Be a sync. A sync load of scripts. You know, if you're using a script tag within your HTML page, be nice. Put a sync on it. If you can't put a sync on it, put defer on it. Don't block. Same thing about CSS, but there it's harder. Again, for those of you who happen to not know, if you put a script tag without a sync or defer, or you put a link tag to a CSS, the browser will halt rendering until that resource is downloaded, parsed, and executed. It will continue processing the HTML in the background. It might even download additional resources, but it will not continue rendering. So for the user, the UI is stuck until that resource is done. So you don't want to block. For scripts, as I said, it's relatively straightforward. There's these two attributes. For CSS, it's harder. There are various tricks and libraries that let you do that. One interesting solution is to bundle your CSS into a bundle using Webpack, which then makes, because the script is downloaded asynchronously, so will the CSS. There are other tricks about using the media attribute, and there are libraries out there which you can also use. Just look for a sync CSS download, you will find stuff. And with resources like images, well, they're downloaded synchronously by default. You just need to be careful not to get in the browser's way. You know, loading an image, don't wait for it. You know, just go on with what you're doing. So, to summarize, you know, this is a very old statement about, you know, premature optimizations, you know, premature optimizations being the source of all evil and so forth. Bottom line is, don't assume that you know where your bottlenecks are. Measure. And constantly measure. Don't just measure once, implement your changes. As your system evolves, as people start accessing your systems from different types of devices, from different geographies, then continue to measure, monitor your measurements. So in conclusion, any goal that you define must be quantifiable. Don't just say, I want my site to load fast. Say, I want my site to load in under 2 seconds or under 1 second if you're trying to abide by Google's guidelines. You know, because if you tell your testers, you know, I want my site to be fast, what does that mean to them? Effectively, it means nothing. But if you tell them, I want my site, I need my site to, you know, to display something to the user within 1 second, that's something that they can actually measure. And that's also something that you can then measure in production. Continuously measure to achieve those goals. So obviously just setting the goals isn't enough. You need to have the infrastructure in place that enables you to perform the measurements to see that you're achieving or approaching or working towards your goals. You want to monitor in order to verify progress and prevent regression. I said that my role is that of performance specialist. Sometimes I think that my role is that of fighting against 60 developers who are constantly adding new features to the product and consequently also always making it somewhat slower than it was before. Sometimes it really feels like death by 1,000 cuts. So you need to constantly monitor your system and see that you're moving in the right direction, that you're not regressing. Check in a variety of scenarios. Just because it's faster in a desktop doesn't mean that it's going to be faster on a mobile device, because the whole network behavior of mobile devices is completely different. Can you, by the way, guess which is the slowest in terms of performance? Desktops, smartphones, or tablets? Can you guess? Tablets. Now, my guess is that the reason for that is that we replace our phones every year and a half or two. Tablets, I'm still using the one I got it as a gift 5 years ago. You know, it's so old and slow, but it's working, so I use it. And unfortunately, we see in real data that tablets are very, very slow and don't have a lot of memory. So nothing beats real data. Try to collect real data. You can use systems like we use, or you can look for third-party solutions and implement them. And remember, whatever you're doing, your customers have alternatives. They don't have to choose your products. They have a million other products and services. In this age of the internet, we can get at customers all over the world, but so can our competitors. And if your competitors offer a better product, a better solution, you know, if your site takes 10 seconds to load, then the user will leave your site and go to the site of one of your competitors. And if their site loads quickly enough, then they will stay there, and they might not ever come back. Thank you very much. So, do I have time for a few questions? Okay, so let's look at the questions. The performance API, how do you control or limit the impact of reporting to the backend? Bandwidth, battery life. Well, let's be reasonable. That's all I can say. I mean, don't try to report every second or every, tenth of a second. Then indeed your customers will be upset. And by the way, likely the person in charge of the backend infrastructure for your information gathering system will be even more upset, because you'll be trying to push so much information into it, and storing information, processing information costs money. So be reasonable about it. I mean, if you're measuring performance of the load process, then we'll start with, let's say, 2 markers for the beginning and the end, and then add 2 more, 3 more, and so forth. And by the way, from my experience, usually the problem is not the problem of having too many. It's a problem of never having enough, in the sense that we are trying to analyze a performance problem and say, ooh, yeah, but this process actually incorporates a whole slew of operations. We really need to break this down into smaller pieces. So you do need to be careful. But in reality, the problem is usually the other way around. Do we measure memory degradation? Not at this point of time, but we are thinking about it. There's actually in the Performance API also ways to look at memory to an extent. We are not doing it yet. In any event, memory use is kind of very difficult to control in an environment like JavaScript. So it's not even if we do gather information, it's not straightforward about how we might be able to use this information. We do look for memory leaks during development. Do you ever have problems with the JVM garbage collection times? Yes, that can be a problem using animation. So we try to minimize the amount of allocations that we do. When we are measuring performance for hotspots within the application, and when you find a real hotspot that has a significant impact on the performance and user experience of your application, then everything's fair game. We will do what it takes. If it means making the code not as nice, doing all sorts of pooling of resources and so forth, we will do that. And in that case, if we identify that the JVM, it's not the JVM, it's not the Java virtual machine, it's the JavaScript engine garbage collection. If we find that it's a bottleneck, then we deal with it. I do have to say that modern JavaScript environments are fairly good. So in most cases, the problem will be you rather than the environment, unless you kind of exploit its weaknesses. Prefetch versus pre-render, when to use. Usually you would use prefetch when you know the resources. Pre-render is more relevant when you're going to be leaving, let's say, the current site for a different site. So pre-render is really relevant when you're loading another page. But if it's within your site, then maybe you might use a service worker instead. But if you're going to a different site, or for some reason you can't or don't want to use a service worker, then pre-render is a solution. Prefetch is more relevant when you're staying within the same page or within the same site. And by the way, the browser is really smart about prefetch. It waits for idle time. It tries not to conflict with other things that are going on interactively with the user within the session. If you ever open the Chrome DevTools on the Network tab, you will notice that there's a column about priority. When something is blocking, it gets the highest priority. When something isn't, it usually gets a lower priority. Things like prefetch have the lowest priority. So the browser is trying to be smart about it. Do you automate performance tests at build time to measure impact of developer improvements? The answer is yes, to an extent, but it's really hard. It's really hard because when you're trying to measure performance in build time, you're impacted by other things going on the machine. So for example, if you're doing a build on your own computer, and you are at the same time, let's say you're running 2 builds in parallel, then obviously that slows down the machine. So if you're just trying to measure a certain operation and say, well, this should take under 1 second, then maybe it took longer because the machine was really busy. So we are looking at various ways to normalize test times. It's not trivial. It's probably worth a session once we get a really good solution for it. So it's not so much at build times, it's more during automated testing time. Any additional questions? Yeah.
Are there any books on this topic which you would recommend?
Books. Well, there's a lot of online resources. Google has a ton of online resources. If you go into, just Google for it. It's a good idea. I'll try to maybe post up additional information. I don't have an idea for a book off the top of my head. There are lots of books on JavaScript performance, but not so much on the overall thing. YouTube is your friend. Google is your friend. That's the best I can say. Chrome DevTools. One of the annoying problems with Chrome DevTools is that the Chrome DevTools is progressing so quickly. Even the online documentation isn't able to keep up. So if you try to read about what can be done in the Chrome DevTools, you will often find that even on the Google site, they're talking about 3 versions back. So it's a problem. What can I say? There was the Chrome Dev Summit recently. A lot of good videos should be coming out of that. I know that the focus was on progressive web apps and service workers, so there should be a lot of content around that. Okay, everybody, thank you very much.